next topic is the operations. On determinants. So we'll find out what are the various operations possible on a given determinant. So first operation is called as the interchange, okay, or the exchange. We can interchange or exchange a ith row with jth row for any given determinant. Similarly, you can perform the exchange or the interchange of ith column. C indicates the column. This double arrow mark indicates the exchange or the interchange, CG. Right? So that's the first operation called exchange. Then we can actually perform the linear addition or subtraction of the elements row wise or column wise. Okay, so this is linear addition or subtraction. So let's try to represent in this fashion. So either you can perform Ri, right? You can try to replace Ri as the current Ri plus or minus a constant m times Rj. Similarly, you can perform the column for the columns as well. So we can write Ci is equal to current value plus or minus some constant times Cj. This is allowed. Is this the only way? No, it's not only this. You can also, right? I can write or. You can perform the linear addition or subtraction of the other row as well. Considering that we have three rows in a particular determinant, you can do the linear addition or subtraction of the first row, second row, as well as third row all at once. So that means I can also write Ri is equal to Ri plus or minus m times Rj plus or minus some other n times the next this thing. So this can actually be extended depending upon how many number of rows or columns you have. Okay, similarly, the Ci can also be written as Ci plus or minus m times Cj plus or minus n times, sorry, this is Ck, Rk and Ck. All right. So like that, you can add or subtract any number of columns multiplied by a constant. So here the m comma n are the constants. Okay, right. Like this, we can perform the various operations. Why do we need operations? Because there are several properties of the determinants which help us, various properties help us in finding the value of the determinant in a very quick fashion rather than solving the whole determinant. Okay, so for that reason, we need these operations. So we'll move ahead. So the next concept will be the properties. Properties of determinants. Okay, now the property number one will check the properties one by one, right? So the first property says that the value of a determinant remains unaltered when the rows and the columns get exchanged. In a sense, rows getting exchanged with the columns. All right, so this implies, right? Let us say there is a delta which is the A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is a determinant. So this is also equal to exchange the rows and columns. In a sense, take a transpose. So A1, B1, C1, A2, B2, C2, A3, B3, and C3. Right? So both will give you the same determinant. Okay, so let us verify this property. We have to verify this property for, let's take an example. So this is the determinant. So calculate the delta is equal to say 1, 2, 1, 2 minus 1, 4, minus 3, minus 2, minus 7. So first we need to calculate this. Then I'll also calculate another delta, that is by making the changes, exchanging the rows into columns, columns into rows, right? So taking a transpose, 1, 2, 1, 2, minus 1, 4, minus 3, minus 2, minus 7. So when we solve, we get both determinants as same, which is equal to 12. Let us move further. The next property says, if any two rows or the columns, right, or columns in bracket, or any two columns, okay, so if any two rows or any two columns of a determinant get exchanged, then the sign of determinant, then the sign of the determinant is gets changed. So you have a positive value, it becomes negative. You have negative, it becomes positive. Okay, this is true for row exchange as well as the column exchange. We'll verify at least one of them. Okay, so we'll calculate, we'll take the previous answer as one of the standard answers. Let's say this is the one we already have calculated. Right, so this is already known. Now we need to verify the property, right? So I want to calculate some delta 1 which is equal to, I'll exchange the first row and the second row. So 2 minus 1 minus 2, 1 2 minus 3, 1 4 minus 7. So this is one which we want to calculate now. And the second one will do after performing a column exchange, right? I'll exchange the second and the third columns, say 1, 2, 1 as it is, then minus 3, minus 1, 4, 2, minus 1, so this is minus 7, a mistake. So minus 3, minus 2, okay, so minus 3, minus 2, minus 7, then 2, minus 1, 4. Okay, We want to calculate the two determinants. So the answer is minus 12 and minus 12 as required. So that proves the property. Next, let's move further. This is property number 3. If any two rows or columns of if any two rows of or two columns of a determinant same, then the value determinant equals to 0. All right, let's directly check this particular property with the help of two examples. Okay, the first one will make two rows same. Okay, so this is 1, 1, 1, 0, 2, minus 4, and 1, 1, 1. Okay, this is the first one. And then I want to check the one with two columns being same. Say 2, minus 2, 4, minus 1, 1, minus 1, 2, minus 2, 4. So both the determinants value becomes equal to 0. Next property of determinant, if all elements of a row or column of a determinant get multiplied by a factor k, then the value of the determinant also get value gets multiplied by k. Okay, so let us take the same old example. So this is the known value. Now I will multiply the elements of the first row by say 6. Okay, so this is 6 into 1, 6 into 2, and this is 6 into minus 3, and rest remains same. Okay, so this is 2 minus 1 minus 2, 1, 4, minus 7. So try to find this determinant. At the same time, we'll try to take up another example. So delta 2 is equal to, and multiply the any one column, okay, by say 6. Rest will try to keep it same. So 2, 3, minus 1, minus 2, 4, minus 7. So the answer here comes 72, which is nothing but the 6 into the previous value, that is 6 into this. So we can see that here first row got multiplied by 6. That's why the result also getting multiplied by 6. Same thing happens with this determinant. First column gets multiplied by 6 compared to the original determinant, right? Because of that reason, here also we are getting 72, that is equal to 6 into 12. All right, let's move further. Right, right. The next property is this. If every element of a column or row is the sum of two items, then the determinant is equal to the sum of two determinants. What are the two determinants? The first one containing the first term in place of each of the sum and the other, in the sense the second one, with the second term of sum. So when we take this, we have to remember that all the other elements of the determinants will remain same. So this is what is the meaning. Okay, so let's try to write this. So let's try to write a equation for this. So this is the statement of this particular property. Now let us say we have a plus x, a1 plus x, b1, c1, a2 plus y, okay, b2, c2, a3 plus z, b3, c3. So you see read the statement. If every element of a column or a row is the sum of two different items, right? You see the first column is sum of two different items, right? Every element is two different, has two different values. Then this can be written as first as a sum of two determinants, first determinant containing the first elements of the sum. So first element of the first row is a1, a1 b1 c1, a2 b2 c2, a3 b3 c3. This is the first determinant. So plus, then we'll write the second part, that is x b1 c1, y b2 c2, z b3 c3. Right, we can see that the second column and the third column of both the determinants remain same. Only that particular what you call a column which had two terms, right, which we tried to split as two terms, right, they got separated up. They are changed in the sum of the two determinants. All right, let's first do one thing. Let's calculate something. Okay, the first thing to note is, let's take the same example which we already have calculated. So that is this one. So we know that there is a determinant like this. Okay, now what I do, I try to write the specific column as a different value, right? So I'll try to write it in this way. So let us say the 1, 2, minus 3, 2 minus 1 minus 2, and 1, 4 minus 7 is actually, I'll try to split this up. So I'll try to write this as, this is 4 minus 3, 2 minus 3. See, because 4 minus 3 is equal to the 1, right? We are trying to write it in this fashion. Okay, all right. Then let me write the second element, that is equal to, okay, this is 8 minus 6, right? We'll write the other elements as it is, minus 1, minus 2. Then I need to give 1 here, so this is, say, right, 3 minus 2. 3 minus 2 is 1, 4 minus 7. So anyway, this determinant is 12, we know that. But I need to find out something like, I will split this. So this is equal to, the same thing, this is equal to, now I am supposed to, I should be able to write 4, 2, minus 3, 8, minus 1, minus 2, 3, 4, minus 7. This is the first half. Plus the determinant of minus 3, 2, minus 3, minus 6, minus 1, minus 2, minus 2, 4, minus 7. So we need to calculate the two different determinants. One we'll write here, plus one more which we calculate we'll write here. So we have the first determinant giving 55. This is minus 43. So we get 12 once again back. That's the original answer, right, which we had here. So we try to split the given determinant into two different determinants. Still the total value remains the same. That's what is the meaning of this particular property. So let's move further. The next property says value of the determinant does not change if the elements of any row or column or column increased or decreased by values of the rows and columns are increased or decreased by linear multiples of other rows or columns. So you can increase or decrease indicating that plus or minus. Okay, so let us uh, okay, let's consider the same determinant. Now we are going to perform, let's do two operations now. So first operation, right, every a row 1 is equal to the row 1 plus 2 times row 2 minus 3 times row 3. Let's try to do this to get a new determinant. So I'll call that as delta 1. This means the delta 1 is equal to the first row 1 will change. Okay, so row 1 only will change, row 2, row 3 remain same. So row 1 is equal to content of row 1 plus 2 times the content of row 2 minus 3 times the content of row 3. So that means 1. So first, this is the calculation. First element is equal to 1 plus 2 times the next row, row 2, that is 2, minus 3 times the row 3, which is 1. So next, 2 times 2 plus 2 times minus 1 plus 3 times 4, right? So we are calculating these elements, okay, right? So the element corresponding to this using these two and so on. Same thing will be repeated for the first row third element, that is minus 3, right? So that is minus 3 plus 2 times the second row element, that is minus 2, plus 3 times the third row element, which is minus 7. So other than that, keep everything same. That is 2 minus 1 minus 2, 1, 4 minus 7. Okay, calculate what is this now. So what's the first element? This is 4 plus 1, 5 minus 3. 5 minus 3 is equal to 2. Similarly, 2 and minus 2 will get cancelled here. 3 into 4, that is 12. Then minus 3, this is minus 4 minus 21. This is minus 28. Okay, so this is 2 minus 1 minus 2, 1, 4 minus 7. Calculate the value of the determinant. So the mistake is we need to change this as minus 3. Okay, and this is also minus 3. So because of that, we have different answers coming up. So this is minus 3, this is minus. So there is change. This value will change and this value will change. Okay. So the change should be 2 and minus 2 will cancel. Minus 3 into 4, minus 12. Okay, so this is minus 3, minus 4, plus 28. 21, my mistake. This is 21. So 21 plus 21, okay. 21 minus 7, 16, right? Okay, plus 16. So this has to be 14 because 21 minus 7, 14. Now we'll calculate the determinant. So this answer is 12. So that justifies the given statement. Let's try the same thing with the columns. Right? So the given determinant is this. Okay. Now I want to make the change like C2. I'll go for a second column. C2 is equal to C2 minus C1 plus 2 times C3. So I'll change only the C2. C1 and C3 remain same. Let's calculate a delta 2. That should be corresponding to C2 will change. C1 remains same, right? So C1 is 1, 2, 1. C3 I will write. C3 remains same. That is minus 3, minus 2, minus 7. first calculate the C2 value. So the second column, minus 5, minus 7, minus 11. Now we use these values to calculate the determinant. So this is equal to 12, no change. Right. Let's move on to the next property. Property states that if each element on one side or both sides of the principal diagonal of the determinant, if each element is 0, okay, is 0, then the value of determinant is the product diagonal elements. So let's take an example. So first one, delta 1 is equal to determinant 1, 2, 3, 0, minus 1, 4, 0, 0, 2. So we can see that one side of the diagonal, right, element, all are zeros. That means this is the principal diagonal. If one side of the principal diagonal, all elements are 0, then the rule says that determinant is simply the product of the diagonal elements. We can actually directly write this is 2 into minus 1. So 1 into minus 1 into 2. So this is minus 2 is the answer, right? Please verify when we write the other. So delta 2 is equal to, let's write another. Okay, so 2, 0, 0, 1, minus 2, 0, 1, minus 1, 1. So here also we can see that this is the diagonal element. One side is 0. Right. That means we can still write this is equal to 2 into minus 2 into 1, 2 into minus 2 minus 4 is the answer. At the same time, even if both sides are zeros, right? We have both sides of principal diagonal zeros. Let's consider that as another example. Like this is 1, 0, 0, 0, 2, 0, and 0, 0, 3. In this case also, it is very straightforward. I just have 1 into 2 into 3. So the answer becomes equal to 6. So if any side of the principal diagonal we have all zeros, which means you can directly multiply the diagonal elements to get the answer. That is the proof of the property.